everyone, and welcome to another episode of Wearing Flip-Flops. We're here again with Sirish, postdoc. Great to have you again, Sirish. How was that for you?
Yeah, DAC was amazing, and I really enjoyed the event. And I was able to interact with all our customers, and uh, happy to see like a lot of research and development going on in AI and design space.
Amazing. So let's see. Last time we touched several aspects. We talked about this build versus buy. We talked about challenges and qualification required. Um, on this episode, I'd like to focus more on and discuss the ecosystem and where we are all heading. And to start with the ecosystem, I wanted to ask if the EDA vendors, the Synopsys, Cadence, Siemens, since they control the simulation, do they have an edge on solutions and companies as your company?
Yeah, absolutely. They have a very, very good significant advantage. And I don't think anyone should underestimate them because companies like Synopsys, Cadence, Siemens have spent decades building world-class simulation tools, verification, synthesis, and debug tools as well. So the tools do generate like enormous engineering data, which they already have, and naturally they are positioned to embed AI into their environments. But I also think just um, that won't help. Like as engineers, um, if you take for example, any of the design, right? Like it starts with specification to architecture to RTL, and then it goes into the verification plans, regression, and so on. So those kind of workflows often cross like multiple vendors. So if just one EDA company is trying to embed AI and trying to sell that, I don't think that's going to be a big issue. But um, definitely, um, if they are going to do this workflows, that will definitely help the ecosystem as well. And
Maybe a question around that.
mhm.
Last chapter, last episode, we talked about MCP, and now you're saying that the vendors actually have an edge. Um, what did they have that is not available to the customers or to third parties like yourself? Is there anything missing in the MCP that you would have wanted Cadence, Synopsys, Siemens, CDA to externalize, so everything would just work better from a third party tooling system?
So definitely, if they expose like a lot of this data, right, like through not just MCP, I think even through API, that will definitely help because in order to
Which data,
patch
for
those,
example?
like it can be simulation data, and let's say we simulation data, and also if at all we want to directly fix some coverage holes, if there is a easy way to do that, like just send some information and they um, create like a nice cover group or those kind of stuff.
So what
So
would you need for coverage, for example?
so coverage, yeah, there are multiple things, right? Like yeah, we might need to do sequences as well, right? So you might need to modify the test bench, and then uh, like rerun the entire thing. So for example, just creating a new cover group or like new sequence is not the end, because then you need to run that tool and then check the output. uh, the agents need to have a feedback like whether that coverage has improved because of that sequence. So
Okay. What
today
about
we
debug? Sorry, if you're still on the coverage. Sorry for disrupting.
No, so I was about to finish. So on the coverage side, like unless you have these sort of feedback, right? Yeah, the agents won't be able to do a good job. So if at all they expose uh, these through either MCP or API, that would be great.
Got it.
So
What
yeah,
about debug then? Because
so in debug,
nowadays,
yeah.
if I'm not mistaken, they all have kind of MCP API into the debug waveform tool.
Mhm.
You have the log files, you have the design. What else do you need?
Oh yeah, this is a very interesting thing because we spent a lot of time on this, especially the waveform data, right? That is of of lot of value because just through the logs you can figure out like most of the stuff, but if you want to backtrack and see where the actual issue is happening, that will be better through waveforms. And also the advantage is you can provide that as an output to the user as well, because users can then um, judge the output that is given by the AI very clearly.
So what are you saying? You need to be um, to have from the MCP that you don't have today?
So basically, the waveform interface, like a very good
Waveform interface.
yeah.
Got it. So
Yeah.
I guess it would be a question, whether it makes sense for the EDA vendors to externalize that business-wise. But let's talk about Moore's Law AI. What are you guys doing in order to gain an edge and to be better 1, 2, 3 years down the road?
We want to take this in several stages. First, we want to stay very laser focused on one domain. So today we are like very focused on verification, and we are diverging a little bit into design and also like firmware stuff. But we are building AI specifically for semiconductor engineering, and that means every day we are thinking about specifications, RTL, coverage, regression, waveforms, debug, and those kind of stuff. And that depth of domain knowledge is difficult to replicate quickly, unless you form a very good team with multidisciplinary fields. And second thing is, as a startup, we always keep our team very lean, and we want to iterate very fast. And at the same time, we are trying to give a very good experience to our customers, both on the support side and on the tooling side as well. And third thing, the most important thing is, as we keep talking to these customers, we are gaining like lot of experience in building this workflows dedicated to our semiconductor industry. Most AI products today automate individual tasks. We focus on orchestration, like we want to completely automate it. We are still not there yet, but yeah, we have a plan to get there. And fourth one is, yeah, we want to be open by design, so we want to be
Maybe just a
flexible.
question on the
Yeah.
automation. In order to automate it, so um, I guess CAD has their own scripts and ecosystem. Are you saying you want to build your parallel ecosystem so a test gets run, tracked with coverage. If it fails, gets bucketed, gets debugged, automatically fixed in the design or the verification, reruns the regression, see that it fails when without the
Mhm.
fix, passes with the fix.
Yeah.
Is that where you're heading?
Yeah, so we are we are trying to build like a platform which can have all these different agents, and people can pick and choose uh, whatever stage they want. Like whether they just want to debug, yeah, they can do the debug. They just want to stay at test bench level, keep writing tests, yeah, they can do that as well.
But
So
would that
basically, yeah,
require
we
also kind of ecosystem platform to run everything, or would you use the customer platform?
Uh, we are completely on customer domain itself. Like yeah, we never host our tools on our cloud environment. It always runs on-prem.
Got it. Actually, it brings
Yeah.
me to the next question because recently Cheap Agent announced that they partner with Amazon, and I'm wondering, do you have any plans to partner with third parties?
Yeah,
I mean,
we are always
does it make sense
yeah.
even to collaborate for a better ecosystem?
Oh yeah, yeah, definitely. Yeah, partnerships are very important, and we are always evaluating strategic partnerships where we can to create like a very good value for our customers, both on the semiconductor companies and also on the AI ecosystem as well. So, uh, because for example, when you're developing a chip, right? Yeah, you actually um, take like several tools. Even if you take EDA tools, right? You take like design tools, verif tools, and there are like bunch of IP vendors. So it is important to partner with all these companies to deliver a very good uh, output to our customer. And recently, if you I don't know if you have seen the DVCon announcement, we partnered with Brecker, and we are trying to build a PSS solution. So there are a bunch of partnerships that
Amazing,
are going to be announced over the few months.
amazing. Um,
Yeah.
Looking forward to seeing that. So, we started talking about that on the previous talk that we had. Looking into the future, 6, 12 months, 2 years, a company as Muslab, what do you need to do and where do you want to expand in order to, keep up? Is it only the kind of the automatic flow, or are there more things that you guys want to do in order to shine 2 years from now?
Yeah, definitely. So first thing is, um, yeah, after we finish focusing on like several stages of the chip development, I don't know. It's a very ambitious goal, but we eventually want to be like a fabulous semiconductor product company, in parallel as well, like providing these AI native solutions. Because then I feel more and more companies can build their own chips very easily. Um, because they can just like come with a product idea to us, and we build the entire chip to them, and um,
In
just
kind of a
hand it over to
service
them.
company to build chips and IPs for whoever wants to
Yeah,
have chip design. Got it.
yeah,
Would
that
that
is
include analog as well, or only digital?
mostly digital, but yeah, we do have analog in our roadmap, because yeah, we were dealing with one of the customer, but right now we are very focused on digital design.
Um, okay, good luck with that. So let's dive into a few, questions of what do you think the world would look like, sooner than later, or in a few months, or even years. Let's talk about UVM. Would UVM stay around? What do you think?
This is a very good question, because I keep debating this with Tom, who is our advisor, and he was one of the authors of UVM. So I would say as LLMs keep becoming powerful, right? It doesn't actually matter which language you choose. I feel yeah, whether you use like any of this Chisel Scala, UVM, Verilog, it doesn't matter at that point.
I would say
So
that it
UVM
might, by
will,
the way.
yeah, yeah, I'm
If you're
coming to
using
that point.
emulation, oh,
Yeah, yeah,
okay, please.
I'm coming to that point. So UVM will try to exist in parallel along with any new kind of hardware languages that are going to evolve. The reason being for two things, because most of the VIPs and stuff were built using UVM, and also yeah, I do agree. for FPGAs because yeah, I started my career with FPGAs and I know what you're talking about there. And um, so I would say UVM will exist in parallel. Yeah, it won't go away for sure.
Okay, but would there be, other ways to verify? For example, do you see more software test benches? Do you see Python-based test benches? How do you envision the future with test benches, if at all?
So it depends on the use case and the kind of chip you're trying to build. Because when I was working for this startup before, prior to Microsoft, right? So we were building like an AI accelerator. So there, we had a very small team, and we had to check the entire this image detection pipeline, and the AI models were written in Python. So we created a bridge between Python and like system Verilog, and yeah, the tests were written on both sides. So I would say it definitely depends on the kind of chip you're trying to build. And these days, as you are seeing, most of the open source languages are also gaining popularity, especially Scala and Chisel, because LLMs understand software much better. So I could see that happening definitely.
What about the design side? How would that be written?
Design I haven't explored much, but yeah, even there, right? Like, um, yeah, there might be new languages, but Verilog and System Verilog will still exist because of the design tools, and design is a little bit more complicated, right? Because it needs to eventually get translated into netlist, and there are like several optimizations that keep happening down the line. I feel design will be the hardest to transform, but yeah, there is still there are a lot of languages that are coming up. We'll see. Even I'm not sure about that.
How about debug? So we talked a bit about
Mhm.
looping and automatic debugging, automatic fixing. Um, Anything else you envision for debug?
Yeah, I would say on the debug side, it would be great if if someone forms a consortium and comes up with an open standard, because right now the biggest challenge that we or like anyone is facing who is building these tools is trying to um, get the data in a very structured manner and feed it through the LLM and do correlation with different aspects, right? Debug is not just one thing where you look at the log or like just see a RTL file. You also need to match that with the spec intent, right? And for that, I wish there will be like some effort on building some sort of open interface that can um, help build this AI solutions much quickly.
Okay. What about waveform? Would that be required? And I'm asking because the more automatic debug happens, probably the less people would have to review the waveform themselves.
Hmm.
Would we
Right.
need a waveform after all?
I feel yeah we will just for us to review. If you talk about the AI side, I think the simulation data and the waveform data it might get transformed into some sort of representation that will be easier for the LLMs to understand. But coming to the waveform itself, yeah, I definitely agree with you. There will be lesser waveforms to look at, but it is always nice to look at like at least the high level waveforms and see the system is working. It will be mostly useful for the human engineers and less for the AI, I feel.
Okay. What about simulation? Would simulation, as we know it today, be required? 2 years from now, can there be that the LLM says, well, the bug, you have a bug in line 20, I read the spec and that's wrong. No simulation is needed. No formal verification is needed. Here are some bugs. Do we still need simulation?
Yeah, I would say if you are trying to build a complex SOC kind of project, you definitely need simulation. Um, it it might be less optional if you are trying to deal with a smaller block. The reason I tell you why simulation is required is eventually you're trying to deal with code, and the way you can verify a code is by running it. So I don't see a easy way to get out of that loop unless your LLM or AI solution is able to internally analyze all the paths inside your design and like tell you like exactly, okay, yeah, here is the problem. And for that reason, I feel simulation is definitely required. But as you know, I could see a future where simulation can become much faster, um, because there are a lot of companies working in that domain, and once that happens, um, it doesn't matter. Like, yeah, you simply run simulation in few minutes, and yeah, you will get the results rather than like your AI or like some tool going and analyzing each and every path in your design.
So what you're saying is that as AI becomes better at debugging and fixing stuff, more simulation runs would be required. Therefore, simulation would become the next bottleneck, right?
Yeah, because you see at that point, right, like the more simulation runs it can do and like it can get a feedback, the better it will be at debugging issues. And
Okay.
you will have a very high quality code at the end, right? So,
What about productivity gains? What should customers expect as for productivity gains?
I would say even today, right, what we are trying to do is we are trying to remove a lot of manual work, like trying to search for data and correlation with specs or anything, right? Those kind of manual tedious tasks, even like yeah, going through the waveforms. I think these kind of tedious tasks will get um, taken care by AI, and it will eventually give you better results. So you can finish your debug within like a couple of minutes or like in maybe hours instead of like days or weeks. So
If we're
definitely you will,
talking about,
yeah.
100 time of the project, let's say a year for the sake
Mm,
of, the discussion, what
mm.
could the customer expect in design productivity and in verification productivity? What would the customer be able to pull in the schedule or do more for a cleaner chip? What do you think? Where are we heading?
So if you are going to take like IoT kind of projects, right? Yeah, definitely you can shrink the schedule. And there, I think most of the interfaces are pretty standard, and if AI can learn those standard protocols, we should be able to uh, finish off the chip maybe let's say in 6 months, right? And but if you are trying to build something like a NVIDIA GPU, right, like which is like super complicated, there I would say you would put more effort in making it better, and there you can like do more and more testing and like have a very high quality chip at the end.
Got it. Thank you. Maybe another question is about protecting the customer IPs. Um,
Hmm.
so you mentioned that in the future you might want to actually be an IP factory. Nowadays, you're providing all the tools on the on-prem at the customer house or compute. Um, but do you see here any security issue that you get from customers or concerns, security concerns, whether it's on their compute with your software or whether it's from other companies as yourself that are taking the customer design to their cloud?
So I'll tell you about how we are doing, and because yeah, I don't know what other companies are offering. Yeah, I do see they offer cloud solutions and also on-prem solutions. But coming to our company, right? since day one, we have we always tell the customers that we never train on your data. Like it is once we give you the software, it is on your premise, and we have no communication onto our cloud or to any of our services. So the all our products today are like on-prem. The only thing the customer needs to get is the a LLM API key, which is like hosted on their cloud infra. It's not on our cloud servers, so it's on their cloud compliance, and whatever data that is going to be generated and interactions that are going to happen is like within their premise. Nothing ever like communicates with our servers at all. And um, the only issue for the customers would be yeah, it's their choice, like if they want to use like either the LLM providers like OpenAI, Anthropic, or any other cloud hosted services, or they can build their own GPU cluster and have their AI models within their premise as well.
Siri, so what would the future bottlenecks be for verification?
So, if I think it will be definitely simulation. Like if we have a simulator that can do simulations faster, that will help the LLMs analyze the results better, because then they can run many simulations and gather all the information and reanalyze the data and maybe fix the design as well.
Thank you, Sirish. Anything else I should have asked you and I haven't?
No, I think yeah, the questions were really challenging, and I enjoyed your interview. And maybe we'll do some product demos in the future as well, and I'll walk you through our flow.
Thank you so much for being with us, and see you all on the next episode. Bye bye.